Alright, I have here three examples on how we're going to factor these polynomials using factoring by grouping. The first thing that we're going to do is we're going to group these 3ax and 6ay simply because both of them contains a, and at the same time 3 and 6 can have a common factor. So let's group them. We have 3ax and then plus 6ay. Now, what is left? We have the group of, say, bx, this one, plus 2by. Okay? So you see, since these terms are all addition, we can rearrange the position of the addends. Okay, now, for the terms. Now, how are we going to factor this? By using common monomial. Okay? The common factors for 3ax and 6ay is nothing but for constant we have 3 and for variable you have a. Meaning, when you divide 3ax by 3a, what is left or what the quotient will be is nothing but x. Okay? Whereas when we divide 6ay, it's just like 6ay over 3a. Okay? What is left is 6 divided by 3 will give you 2. And this a here cancels out. And then we have y as your quotient. Okay? For this group, okay, we're going to factor this also using common monomial. So, what is the common variable here? So, we have here b because the variable b is present in both terms. So, it's just like dividing bx by b. Okay, what will be the quotient is nothing but x. And when we divide 2by by b, okay, we have a quotient like 2y. Now let's check if this factoring is correct. Okay, to check that, once again, we have to use the process of distributive property. When we multiply 3a by x, we have a product of 3ax, and this is 3ax. Now we multiply 3a by 2y, we're going to have 6ay, and this is your 6ay, meaning to say this term is correctly factored. Now let's go to the other term. Okay, when we distribute b by multiplying it with x, we have bx, and this is our bx. And when we multiply b by 2y, we have 2by. So meaning, for the two terms, we are able to factor them correctly. Now you will notice finally that we have term like this, 3a, then quantity x plus 2y, and plus b, quantity x plus 2y. You will notice that this x plus 2y is common to both terms. For these two terms, the common factor is x plus 2y because this term also contains x plus 2y as a factor. So we can factor this out. We have now x plus 2y, okay, multiplied by the remaining factor. We have 3a plus b. And now, this is your factored form of this algebraic expression. X plus 2y multiplied by 3a plus b. Okay, so for the next example, we have x squared plus y squared minus z squared plus 2xy. For number 2, we have an expression like x squared plus y squared minus z squared plus 2xy. Okay, at first, this expression looks confusing if how we're going to group them. But obviously, this x squared plus x squared together with 2xy can be a group of trinomial that can be factored using perfect trinomial square. Now let's do it. So let's group this as x squared plus y squared, alright, minus, okay, maybe we can write first the 2xy. Again, this is commutative because addition, so we can put the order of addends in any order. Okay, and then last we have plus y squared. Okay, now this is our first group. The other group will be this one, negative z squared. Alright, so notice that this can also be factored using perfect trinomial square, because we have a square here and square here, and when we divide this second term coefficient, which is 2 by 2, we're going to have xy. Okay, and this one we're not going to solve this. It will remain negative z squared. Okay, let's solve this first. The factor of this is nothing but, okay, x plus y squared. Okay, the factor of x squared plus 2xy plus y squared is x plus y squared. Okay, let's try to check. If we're going to expand this, x plus y, and then multiply by itself, okay, let's check if the product of this or the expansion of this binomial will be equal to this. Okay, so this x and x here, when you multiply them, it's going to be x squared. When you multiply y and y squared, you have your y squared. The middle term now, when you multiply this, it's going to be xy as well as this one, xy. So when you add them, you have your 2xy. And this is exactly the same as this one. So this one. And then we can conclude that truly, this is the factored form of this expression. And then we're going to write minus z squared. Now having that done, what do you have in mind after we factor these three or trinomial? Can this still be factored? Of course, it can be factored. How? You notice that the sign here is negative, meaning it's going to be a difference. So this is a square and this is a square. So what you will think of the type of factor that we're going to use is nothing but the difference of two squares. So let's put a bracket here, and then another bracket here. Alright, then minus one bracket here and another bracket here. So since this is negative, we're going to have one positive here and one negative here. Alright, so what is the square root of x plus y squared? It is nothing but x plus y. Okay, and we're going to put here x plus y also. Alright, and what is the square root, or what is the factored form of z squared? It is nothing but z and another z. So this is now the factored form of this expression, x squared plus y squared minus z squared plus 2xy. Okay, what kind of factoring did we use? First, we group them and we factor this using your perfect trinomial square, and we did not compute anything with this term. Okay, we just bring this one down here, and then after that we found out that these remaining answers or terms here can be factored further using your difference of 2 squared, and the answer is the quantity x plus y plus z and another quantity x. This should mali dapat tama. So the factored form of this is x plus y and another x plus y here. Okay? There. And the only difference is one positive here and one negative here. And the square root or the factored form of z squared is nothing but z and another z here. Okay? So this is now the answer for number 2 using factoring by grouping. Finally, we have example like 4m minus 4n plus m squared plus 2mn minus 3n. Notice that this is obviously can be factored using common monomial. So for number 3, we have expression like 4m minus 4n plus m squared plus 2mn minus 3n. Now you will notice obviously these two terms can be factored using common monomials because we have coefficient of 4 and 4 here. So let's group them. So this can be 4m minus 4n. Okay, this is our first group. And then we group this as m squared plus 2m n minus 3n squared. Alright, so this is easier to factor using common monomials, and then we have now 4 quantity m minus n. Obviously, when we check this using distributive property, 4 times n will give you this much, and 4 times negative n will give you negative 4n. Meaning to say, our factoring here is correct using common monomial. Let's try this. Okay? Now, for m squared plus 2mn minus 3n squared, it's a little bit challenging to factor this trinomial. However, there's a way we can factor this. Okay? So, since we have negative sign here, we must have one positive and one negative here. Okay? And then since we have m squared here, you can write here your first m and another m, meaning m times m will give you m squared. And since we have 3n here, we can write here that 3n and here an n, so that when you multiply this, it will give us negative 3n. However, we have to satisfy the condition on the second term, that when we get the product of these two will give us 3mn, okay, and this one should give us negative mn. So m times negative n will give us negative mn. And when we find the difference of these two, so our only concern here, since we know that m multiplied by n will give us m squared, and 3n multiplied by negative n will give us negative 3n squared. Okay, we need to satisfy the condition that the middle term will be equal to positive 2mn. How are we going to do that? By just multiplying these two terms here, 3n multiplied by m will give us positive 3mn. And when we multiply by this m by negative n, it will give us negative mn. When we get the sum of these two terms, we are going to have 2mn. That's positive. That is the same as the middle term. Meaning to say, that only concludes us that this m plus 3n multiplied by m minus n is the true factored form of this m squared plus 2mn minus 3n squared. Okay, so we have no common monomial between these two factored form. And the common monomial will be m minus n and another one m minus n. In other words, our final answer will be nothing but, you get this common monomial m minus n, okay, multiplied by these two factors. So we have 4, and this is addition, plus this one, m plus 3n. Okay, so this is now the factored form using factoring by grouping for our algebraic expression 4m minus 4n plus m squared plus 2mn minus 3n. Just notice that when we separate or when we group these two terms and these two terms, we tried our best to factor this further. By observation or by ocular inspection, we know that this can be factored using common monomial. And this is a little bit challenging, but still we were able to get the factored form for this trinomial. And the answer is m plus 3n multiplied by m minus n. And when we do that, we notice again that the common factor for these two groups now will be m minus n and another m minus n. And that is the thing that we factored out here, so that the remaining will be 4 and then the positive m plus 3n. And when we multiply this using a spatial product, then we will be able to arrive at a product or expression like this. Okay, so these three examples of factoring using grouping is a little bit confusing at first, but when you practice this on a regular basis, okay, you will get used to identifying which term can be grouped and factored further. And at the end, most of the time, the last factoring method that you're going to use is common monomials. Okay? So thank you very much for listening, and I hope you learned something from this video of mine. Hope to see you again in my next video.